Welcome to 1.3 video lesson. Today we're talking about domain and interval notation. So you'll recall from previous math classes that domain relates to the x values of a function. Okay, in order to talk about the domain, we need to know where the functions are defined and undefined. So undefined means that you take an x value, and when you substitute it into the function, you get an answer that wouldn't make sense for y. And we're going to talk about a couple different of those scenarios in a minute. Defined means that you find all of the x values that make sense. Now we know that for most functions, there is an infinite amount of x values that make sense. Okay, so sometimes it's a little bit easier for us to instead find the undefined values and then assume that all of the other x's are defined and kind of construct our domain just by eliminating those ones that we know do not work. Okay, so let's look at a couple different graphical examples and see if we can determine, where it's defined, where it's undefined. So this first graph would be defined everywhere, okay, because you can see that that is continuous, meaning I can graph that entire function without picking up my pencil, and there are no breaks or jumps or holes in the graph. So all x values are defined. Okay. For my second graph over here, we see that we have a hole in our graph. So that x value, we could say that's somewhere around x equals 1. That would have to be excluded. Okay, so we are undefined at x equals 1. That could not be part of our domain. In example 3, I have an asymptote. Okay, so we see that the function gets closer and closer to that on either side. It's never actually going to cross it, therefore it does not equal. Okay, so while graphs 2 and 3 look totally different, they are both undefined at x equals 1. So their domains would look the same. Okay, and then our last one is undefined at x equals -1, this open circle. There's a hole over there, and actually this one is undefined in between this open and closed circle as well, because none of these x values are being used either. Okay, so when we're finding the domain, we're gonna, like I said before, we're gonna determine which values are undefined, and we're kind of just gonna use those to eliminate from a domain of all real numbers. Okay, so we're going to start by assuming that the domain is all real numbers, and then systematically we're going to calculate, well, what's going to be undefined. Okay, today we're looking at 3 different situations that are going to cause undefined values. So we're going to deal with rational functions, we're going to deal with square root functions, and then we're going to deal with rational functions that have a square root in the numerator and the denominator. Okay, so if we look at example number 1, we want to first think to ourselves, well, what is going to make this undefined? Okay, would there be any values for this function that are undefined? So number 1 is a rational. So for rational functions, when the denominator equals 0, that's going to produce an undefined value. So we're going to figure out, well, what is that value here that's undefined? So x minus 3 equals 0. That means we cannot have 3 in our domain. So I like to use a number line when I'm getting started with my domain. Okay, 3 is the only value that I'm excluding, so I'm going to use an open circle on that. And we remember the left side is negative infinity, the right side is positive. So other than that 3 that makes this undefined, I can use all other x values for my domain of this function. So what's my interval going to be? Okay, I'm going to read my number line from left to right. So I'm including values from negative infinity up to, but not including 3. I'm skipping over 3, so I'm using a union, and then I'm going to include everything from 3 on to positive infinity. Okay, so remember, values that are not included use a parenthesis, and infinities are always parenthesed. Okay, so that is our domain. For example number 2, okay, a square root function, well, we have to know that we cannot square root a negative number. Okay, we don't deal with imaginaries in this course. So if this has to stay positive, what is underneath the radical has to be positive, I want to limit that to make sure that it's greater than or equal to 0. I want to keep it from 0 in all of my positive numbers because I can do the square root of 0. Square root of 0 is possible. Okay, so that means that all the x values that I have to use, okay, solving this inequality, has to be x is greater than or equal to 3. Okay, so if it's equal to, I'm going to use a closed circle, and greater than or equal to would be over here. So what's my interval going to look like? What values am I including? Well, I'm starting at 3, and that's included, and I'm going up to infinity. Okay. So bracketed 3 to infinity is my domain there for square root of x minus 3, because I have to make sure that what is underneath the square root does not become negative, and I do that by limiting it to be greater than or equal to 0. Okay, now example 3 is going to put both of those concepts together. Okay, so the first thing we're going to see is the square root in the numerator. That's the easier of the two square roots. So the one in the top, we're going to treat just like a regular square root like we did in number 2. We're going to set it greater than or equal to 0. The one in the bottom, however, it has to satisfy 2 requirements. Not only does it have to be positive, but now being in the denominator of a function, it also cannot be equal to 0. So how do I handle that? Okay, when I limit it to be positive numbers, I now just do not include the 0. Okay, so that's all right for you to do. So a square root in the denominator, we limit it to the positive numbers, but we do not include 0. Okay, so now I have 2 statements. I need to look at those on a number line because I can only use one encompassing statement to make my domain. I want to make sure that I satisfy both of these statements. So one says I have to be greater than or equal to -1, and the other says I have to be greater than 3. So what is going to satisfy both of them? Only greater than 3 satisfies both of those statements. Okay, because I can't use something in here. I can't use 0 because 0 would not be greater than 3. Okay, that doesn't work. So instead, my domain here is going to be 3 to infinity, and I'm not going to include the 3 since that came from the square root that was in the bottom. And this guy cannot be equal to 0 in the bottom. Okay, so those were the 3 different situations that we're going to encounter today with domain. Okay, we can try do a couple more. All right, so again, just a regular square root. We're going to take what's underneath and set it greater than or equal to 0, making sure it's only positive values. Okay, if you want to start to pull back on using the number line, now would be a good time to try that. But there is no penalty for using the number line. So if you want to continue to do it and it helps you, by all means, go ahead. All right, so if I'm greater than or equal to -5, my domain is going to be a bracket -5 to infinity. Okay. All right, example 2 now. It's a rational function. I've got a square root on the top. I don't have a square root on the bottom, but I do have a variable on the bottom. So the denominator is going to provide an undefined value. Okay, so the square root in the top, we treat that just like a regular one. So that's going to be greater than or equal to 0. Okay, the denominator now, I'm supposed to set that equal to 0 and solve. So now I know that x cannot be equal to 0. So I want to combine these two statements here and make sure that I'm satisfying both of them. So the first one says greater than or equal to 0. So the greater than portion would be over here to the right. But the second statement says, well, no, you can't actually be equal to it. Okay, so to satisfy both, we're going to use an open circle, but we are going to be greater than 0. Okay, so my domain here is going to be 0 to infinity. All right, number 3 now. Okay, this is strictly a rational function. There's no square root. So the only thing we have to do for a rational function is figure out what makes the denominator undefined. Okay, in this case, we're going to want to factor this. So this is a difference of squares. So I'm going to have 2 undefined values in the denominator. So I get that x cannot equal -5, and I get that x cannot equal +5. Okay, so for this one, we may want to put this back on a number line. Okay, just to get a visual of what's happening here, because this is the first time we're seeing this. All right, since we can't equal either one of those, we're going to put open circles. Okay, but all of my other values surrounding this are acceptable. Okay, so remembering the left side of my number line is -infinity, and the right side is +infinity. Okay, what will my domain be? What interval am I looking at? Well, I see I have 3 separate unions, okay, because they're being cut off by those open circles. So I'm going -infinity to -5, skipping over -5 with a union, okay, but those values -5 to 5 are acceptable, skipping over 5, and then 5 to infinity. Okay, so I have 3 separate intervals for this third example because I have 2 undefined values that are splitting up my domain. Okay, so those are your examples here today for domain. Please make sure you have all of your completed notes down and write down any questions that you have so we can go over them when we're together the next time.